Hello everybody. A lot of people are asking for a rigging tutorial, and I thought I would make one. Now we have the character object in Cinema 4D that you can build a rig in a modular way, but it's better if you know some basics about rigging, you know how rigging works, so you can use this properly, and maybe you can modify it or make your own rig for that matter. Now before we get started, there are some basics that we should get out of the way, which is the Cinema 4D priority system. Now the way priority works in Cinema is, imagine that in every refresh of the program that all the expression and deformers and generators will be executed one time, and it's all about which order they are being executed. Now the order which Cinema 4D uses by default is on the object manager. It executes everything from top to bottom, and if they are expressions, then from left to right. Now what this means is, imagine here that this is the order of execution. We have first we have our cube, second the cone, and third the ball. And what we did now is, let's say we constrained the cone to the cube and the ball to the cone. So these guys are constrained. Everyone is constrained to their upper level. Now if I execute this in Cinema and I animate the cube, what will happen is, first the cube will move, right? Then we're going to the next object and the cone will follow the cube because its constraint is being executed. And then the ball is following the cone. So every frame there's going to be this kind of execution. Now what will happen if we change the order of execution? So let's move on and let's see what happens. I will move the ball up and the cone on the bottom, but remember, the cone is constrained to the cube and the ball is constrained to the cone. But the order of execution is as follows. First, the cube will move. Second, the ball, the constraint of the ball will be executed. Third, the constraint of the cone will be executed. Now what will happen is the cube will move first. Then we go to the sphere. Now the sphere is being constrained to the cone, and the cone has not been executed yet. That means that the sphere will stay where it is, and then the cone is executed. So this is during one execution cycle, which is probably one frame, in which case we can see that the ball will stay behind one frame. Now if we move to the next frame also, let's see what happens. So the cube is being executed first. Again, the ball stays where it is. The cone is executed, is following the cube. And then we move to the next cycle. The cube moves. Then the sphere is being constrained to the cone, so it's going to move to where the cone has its new location. So the sphere is going to move, and then the cone is going to move. So you will see the sphere will always stay one frame behind because of the execution order. Now let's make an example to see this in action. Let's make a sphere, a cube, a sphere, and a cone. And let's give a color to each object. So I'm going to give the same colors I did in the previous example. Green for the cube, blue for the sphere, and red for the cube. Yes, for the cube. And let's use the lines mode here. Let's go to isopams. Alright, so again I'm going to constrain the cone to the cube. Now in order to do that, we have some preset commands on the character menu here. We have a bunch of constraint commands, and the way they work is first you select the object you want to constrain, then the target you want to constrain it to, and then you select which constraint you want. In this case, I will use a PSR constraint, which is position, scale, rotation, and it automatically creates a constraint tag. It enables the PSR, and it applies the cube as a target. I'm going to disable scale, we don't need that. Now if I move the cube, it takes the cone with it. And then I'm going to constrain the sphere to the cone. So first we select the sphere, then we select the cone, then we add the PSR constraint. And we're going to disable the scale again. So if I move the cube, it's taking everything with it. Now the execution order is correct because the cube does not have any expression running, it's just the user. And then the cone is being executed, it's being constrained to the cube, and then the sphere is being constrained to the cone. So it is our first example over here. Let's move this to frame 90. So we're having this execution, which is the correct one. So I move the cube, everything is following properly. Now if I change the order of execution and I move the cone on the last, so first the cube will move, second the sphere is going to look where the cone is, and then the cone will be executed, will look where the cube is. So now if I move the cube, you will see the sphere is starting to lag behind. It's lagging behind one frame because it's failing to update to the correct position to read. It cannot read the position of the cone like that because the cone is executed last. Now if I move this far away and I undo, you will see the problem more obviously. Now in order to fix that, we can either put it on the correct order, or the tags, like the constraint tag on the basic tab, they have some priority settings here. We can set its priority category, so from top to bottom is being executed first, is being executed last. And for each category we can put a value from minus 499 to plus 499. Now by increasing this, we're making this run later. So now they're both at expression level 0. That means that all it matters is their order on the object manager. Now if I put the sphere on a higher level, like 10, it's going to be executed later than the level 0, that is the cone, even though it has a higher position on the object manager. So now if I move the cube, you will see it's working properly again. Alright, so having that out of the way, let's start rigging, shall we? So I made an example here based on a character from the character animation school animation mentor, which is called Bolly. I think it's a nice character for making some example for demonstrated rigging. And we're going to start by making a simple, standard IK leg rig. Now what will the IK leg rig do? First of all, we need a controller for the leg. Let's draw a controller. Let's go on the top view here, and with my linear spline tool, I'm going to enable everything. With my linear spline tool, I'm going to just draw something, and I'm going to hold Alt D to disable the axis here, and draw a simple outline, and close the spline from the spline's attributes. And then I'm going to select these 2 points and bring back my axis and scale them down on the Z axis. Select these 2, scale them down on the Z axis, and well, let's select these 2 guys and give them some position in the middle, so we can enable our snapping tool actually and just bring it over here and then bring them up, and I will do the same thing for the bottom points. So they are right in the middle of the leg. Well, very simple. Let's go to the front view and let's bring this up a little bit. And since it's the left leg, we're going to paint this blue. Alright, so we have our controller. Now let's name this L leg control. So I'm using the L prefix for the left side, which is kind of standard thing to do. And then we want to draw our joints. Let's go to the side view. On the character menu, bring up our joint tool, enable our snapping with axis snap enabled. And by holding Control, I can start painting joints. So I'm going to put one on the thigh, one on the knee, one on the ankle. And I'm going to stop here because I want to make a different chain for the foot. I'm going to try to keep things separately so I can have more control in a cleaner fashion. So by deselecting the joints, now the joint tool will start making a new chain. So again, first to the ankle, then to the toes joint over here, and then I'm going to enable the vertex snap and make one on the tip of the foot over here. Great. Now let's name them so we don't lose track of them. This is the L foot. This is the L ankle root, the L toes, and the L toes tip. And then we have our leg, L leg group with our L thigh, our left knee, and our left ankle. So basically the tip joint is not so important about its rotation, and because it's just there to define the bone. So a bone is being created between two joints if one is child of another. So the ankle is on the other side because it's here that it's on the start of the bone. We're not so interested on the joint that is on the tip of the bone. Now that I created everything, let's select all the joints and go to the coordinates and freeze their transformation. And I'm going to disable the snapping. Great. So we have them at their default position. They have 0 coordinates, so we can always zero them out. Now to make an IK chain, all we need to do is select the root joint and select the end of the chain which we want to make, and go to the character, and on the commands we have a preset command here to create IK chain. So let's run this, and it creates our IK tag. It places the end joint correctly, and it automatically creates a null object to use as a goal. So if we use this, we see that it's not really bending, and that's because it's bending on the wrong side. If I move this here, you can see it's bending sideways. And the reason for this is because the joints are completely straight, so it didn't really know on which side to bend, and it's just guessing now. And we're going to take care of that. But first of all, let's hide the parts of the mesh we don't want to see. Now, because we were drawing on the side view, the snapping was using the auto snapping, which was in 2D mode, so it only placed them on a certain plane, not on the depth. It only snapped them on the YZ plane. So let's make a group of all our joints here. I'm going to select the leg and group it on itself and name this left leg joints. And then I'm going to parent the left foot on the same group. So I'm taking everything with it, and I'm going to drop the goal also under this. So it's taking the whole rig. And I'm going to enable snapping and bring it right in the middle of the left leg. Great. Now let's fix this goal situation. And the way we're going to do that is by going on the left leg that we made the IK rig, and we're going to make a pole vector. Now the pole vector is something like the up vector constraint. This will make another null object where the IK chain it will be aiming at. It will control the banking of the whole IK chain. So let's make our pole, and you can see the joints already rotated somewhat, and it made a new null, which is our pole vector. Let's bring it out, bring it forward and up. So now you can see it controlling the banking of the chain, and it's aiming with its -x. You can see the axis of the joints. I'm going to change that. I'm going to use the y-axis as the banking because I'm used to this, and it's the default actually. If you draw the chain a little bent, it will be using its y-axis. And now if I move the goal up, you will see it's bending on the direction we want, but the foot is not moving. Now the foot, we could parent it to the ankle, of course, but you will see that now it's rotating along with the rest of the rig, and we don't want that. We don't want every time we pull the leg up to have the foot dive under the surface here. Let's put a floor, and you can see that it would just go under the floor. That would cause a lot of problems in animation. Now we could constrain it, but if we're going to constrain it, there's no reason to have it in the same hierarchy anyway. So let's just have it clean outside. And what I'm gonna do is I'm going to take my control that I made before, and I'm going to make sure that its pivot point is where I want it. Now in this particular case, you can put the pivot point wherever you want. I'm going to use the ankle for it because that way I can rotate it in the same fashion I would rotate an FK chain. So because the joint is here, it's just comfortable for me. So I'm going to enable the axis mode here, the snapping, and bring it right on the ankle, and disable the snapping and the axis mode. Now this has the exact same position as the ankle joints, which means it has the same position as the goal. I'm going to parent the goal to the leg control. So now by moving the control, it's taking the goal with it. And since it has this position, I can constrain the whole foot chain to this control. So by selecting the left foot and selecting the left leg control, we're going to go to the character constraints and add a PSR constraint. And I'm going to disable the scaling out of habit, basically. So now it's taking the whole foot with it, and you can see this foot is no longer rotating downwards every time we move it up. Now to see this better, I'm going to constrain the mesh as well. And this mesh is kind of mechanical looking. I don't really need to weight it. I'm just going to constrain these parts to the joints. I'm going to make a few nulls to do that. So we need a null for the thigh here. So this will be the thigh group. And let's duplicate this. This will be the knee group. Let's duplicate this. This will be the ankle. Actually, it will be the foot base group. So it will be just this part. And then we want the toes group. So let's take everything, put it under the mesh, under the left leg, and we're going to start constraining it to our joints. So let's unfold our joints here, and let's bring up our constraint commands as a floating palette. So we don't need the... Actually, let's keep the other commands also to see some more commands from the menu that you may not know yet. So let's start constraining. So the thigh group, we want it to be constrained to the thigh bone, right? Let's add the PSR constraint. The knee group, we want it to the knee bone. Add the PSR constraint. The foot base group, we want it to the ankle root, like we said before, because this is controlling the correct rotation for this bone. So add the PSR constraint. And the toes group, we want it to the toes. Add another PSR constraint. Now let's start parenting the meshes to their appropriate groups. We want this whole part to be on the thigh group. So we have another command here, set parent. We can select the things we want to parent, then click send parent, and we have a pick selection, and we can select either in the viewport or in the manager the object we want to parent them to. So I click on the thigh group and they're going to be moved under the thigh group. Let's do the same for the shin here. Let's use the set parent, drop it under the knee group. On the foot base, we want this joint here and this part over here. Let's set parent, foot base, and finally on the ball and the toes, set parent, toes. So let's see what we have. First of all, let's select everything. I will just middle click on the group to select all the hierarchy, and I'm going to add them to the mesh layer that I made. Now I'm going to lock this mesh layer so it's not messing with my selection on the viewport, and I'm going to disable this plane, and by selecting my foot control I can move it up and we can see it's working. So basically we made our first rig. We can see now some weirdness which is happening. You see this line over here, that is from the IK expression, and when this line will move above the pole vector, well, my joint chain is going to rotate the other way, as you can see. So we don't need to worry about that yet. Let's undo, and the reason I have to undo is important, is because I still haven't frozen the transformation of my control, so I don't remember these values, of course, to reset it to the default position. Let's freeze it. Now I don't need to undo anymore. I can move it as I want. If I want it to go back to the default position, I just click this button over here. Great. Now let's make an inverse foot setup. What is an inverse foot setup? Well, now a human leg, we're used to it so much, and it's doing some very standard movements like walking, in which when we animate a walk, we would like to have some helper pivots, right? It's a very standard movement. We're going to do this a lot. And what we're going to do with an inverse foot setup is we're going to build in our rig some preset pivot points to help us with the animation. Now when a leg is moving, it's going to, let's say, hit the floor like this on the heel. So we want to rotate from the heel. Now if I rotate this, it's rotating from the ankle. I want to rotate from the heel. Otherwise we would have to keep counter animating. Let's say we record the pose like this, and then we drop it on the floor, but then we have to move it like this forward and compare positions, make sure it's not going to slide. Then when it's going to roll off, we want it to rotate the toes, right? We want to step on the toes, so we have to rotate the toes, but then we have to rotate the whole foot and then bring it upwards. We're going to be doing a lot of counter animating if we don't put some preset pivot points, and this is what the inverse foot will do us. So I want a pivot on the heel, a pivot on the toes, and a pivot on the front of the foot for the whole leg. Let's start by making a few null objects. So this will be let's name it heel roll, and enable our snapping, and we want to enable also the edge snap and the midpoint snap. And let's bring it on the back, on the middle of the heel here. Then let's make another null, which will be called ball roll. And let's bring it on the toes joint over here. And let's make another null, which we will call toes roll. And let's bring it in the front. Now the way to make the inverse foot is just some hierarchy rigging, basically, with our goal. So let's see what happens if I drop the ankle goal under the heel roll that we made. Now if I rotate this, you will see that it's taking the goal with it, as apparent that it is, but the foot is staying in place. So we need to take the whole foot with us as well. And the foot is already constrained to the leg control, so maybe we need to make another null and have it be constrained to the null instead of the control directly. So let's make a child of the leg control, zero its coordinates, and name this ankle target. And let's open our joints hierarchy here, and on the constraint of the foot, let's change the spline with the new null that we created, the ankle target. So this null is taking the foot with it, the goal is taking the IK leg with it. So let's drop both of them under our heel. So by moving the heel, it's taking everything. By rotating the heel, it's rotating, but it's now rotating, as you can see, from the pivot point that we want it to rotate. So now we have two pivot points on our rig. We have our heel, so we can rotate our leg from the heel, and we have our ankle. We can rotate the leg from the ankle. Now, of course, if we do rotate the heel, well, the ankle will no longer be in the correct position. It will be offsetted, but that's a good enough compromise. We're going to be using one pivot point at a time. If we're going to use all the pivot points at the same time, well, we cannot really have it working properly with keyframes, right? So next we want to make our ball roll. So again, we want to constrain these guys under the ball roll. Let's drop them under the ball roll and try rotating the ball roll. We can see that the toes is moving also, and we don't want the toes to move. So basically we want to take this back part but have the front part still aiming forward. So the front part is these two joints, and basically it's this joint that's controlling the whole rotation. So we want it to keep facing forward, and the way we're going to do that is we're going to make a target here and have it aiming at the target. Now let's make a break and go see how target constraints work. Let's make a pyramid and have it aligned on the z-axis, because this is the default for the aim. And let's make a sphere as a target. So we can select the pyramid, the sphere, and add a name constraint, which adds a constraint tag with a name and the sphere as a target. So the pyramid is always aiming at the sphere. You see the point, it's always pointing at the sphere. Now the problem is that the twist of the pyramid is not constrained anywhere. So if I can freely twist the pyramid, but I cannot change its other alignment. And this will make our pyramid unstable when it's doing all the matrix calculations. Let's take a look what will happen. Let's move our sphere, let's zero it on the X and the Y, and let's zero the rotation of our pyramid. So let's say our pyramid is aligned like this, and we start messing with our sphere here, and you can see that the twisting of the pyramid is completely unstable, and we need to fix that. So we're going to use an up constraint. Usually the up constraint goes hand by hand with the aim constraint. So the up constraint is going to control the banking of the pyramid. Now you can see on the aim constraint we only have one axis to choose from. But if I make an up constraint, and you will see the pyramid is snapping into place, we have two axes to choose from. So this is the axis that is the banking that we're interested in, and then we have to choose one of the other axes to be aiming at something. Now by default it's aiming at the world axis, so by setting this to y plus is using the y plus of the world to align it to. Now I want to add an object as a target because I don't want it always to be aligned to the y plus. I'm making a cube which will be my up vector. This is going to be the up vector, and I'm going to drag it into the field here. So the y of the pyramid is going to, the banking is going to be aiming at the cube here. So the cube is controlling the twisting. And this is how aim and up vectors work. Now let's close this. And we need to do the same thing with our toes here. So first of all, let's make a target for the toes. We don't want to use the same null as a pivot, and we will see later why. So this is the toes target. And let's snap it here on the front. And I'm going to also select the ball roll here and just make a copy on the right and delete all its children. This will be the ball roll up vector. So I'm dragging it outside of the rig because by experience this seems to be a more stable position than the inside. So let's take a look at the axis here of our ball roll joint. So we want this to my left toes here. Let's make a constraint. And let's disable this, because if I enable aim, you will see it's snapping by default because it's going to use the world axis by default until I place a target in here. So the reason I want to disable it is to make sure it's not snapping out of its default position when I enable it. So let's disable it, enable the aim, and we want to use our toes target that we just made as an aim target, and I want to use an up vector with the minus x axis aiming at this point over here. So actually let's disable snapping and let's give a shape that we can recognize to this up vector, so we can see it visually. And we want this up vector to be on the z-axis that we used for aiming, and this time it will not be the y plus, this time it will be the minus x. So let's use minus x here and pick our up vector, and now if I enable it, it shouldn't move. So I enable it and it's not moving because it's using the exact values that we wanted. So this toes roll null, this a toes target null that we made is controlling the aiming of the ball and therefore the rotation of the ball joint. And this is controlling the twisting. So we want the up vector and the ball roll to be siblings. We want them to always move together. So our ball joint will not be twisting out of place. So now if I rotate this, you can see it's taking the whole foot as I wanted it to be as a pivot point. So now let's take these two together and drop them under the heel. So now by rotating the heel, you can see there is still one part missing, is this toes, this new toes roll that we made. Let's drop this also under the heel. And now, not the toes roll, the toes target. The new toes target that we made. And now this is also taking everything with it. Therefore, it's a pivot point for the whole foot of the heel. And finally, we want a pivot point from the toes. Now we can either drop this, we can either drop the heel under the toes and take everything with the toes, or drop the everything under the toes roll and then under the heel. Basically, if we want to use them together, it depends which one should have the priority. Yeah, I think I will leave it like that, with the toes last. So we have our control here, that it's taking everything with it, it's rotating around the ankle. And then we have a heel roll pivot, we have a toes pivot, we have a ball roll pivot. Yeah, and then we need an easy way to control these pivots. So I'm going to make a user data for our controller. So let's select our controller and let's make a user data. And I'm going to keep it simple. I'm not going to make a bunch of controllers for everything. I'm going to name this foot roll. Make a slider and use degrees. So this foot roll is going to use a combination. On the back, it's going to rotate with the heel. So I think a value of something like -70 should suffice. I don't want to limit it though. I just want to limit the slider, so the presets would be easy to use. So let's use -70 degrees, and the front will use the ball roll. Let's say how much front we want to take it. Let's say around here, 120 degrees. And let's disable our limits. So the slider will be going from -70 to 120, but you can still go more than this value if you want. Alright, so we have our foot roll, and let's make another user data. I'm going to delete it. I'm going to just copy my foot roll because it's already set to slider and degrees, and this will be toes. So this will rotate the toes. And let's say from -90, no, this is correct. Let's limit the slider from -90 to +90 degrees. And again, disable the limits and hit OK. So we have these two sliders. And we're going to rig them using Espresso. So let's right click and make a new Cinema 4D tag Espresso. Drop our leg control here, and let's bring our user data. We have a foot control and a toes control. And then what we want to control is all these nulls that we made. We want to control the heel, and basically in all of them we want to control the pitch, the rotation P. Alright, so I'm just going to make a rotation P and then make a bunch of copies for this node, and I'm just going to drag and drop the other objects and replace it. So ball roll, and we want also the oh, there is one thing I forgot actually. One more thing that we will want is to control the joint, the toes rotation as an FK, right? And I made all the IK here, but I forgot the FK. And this is why we want a different object as a pivot for our toes and as a target for our toes. So we're going to make a new ball roll, a new null at the ball here, and delete all these children. So delete all these guys and name this toes FK, and drop the target under it. So now by rotating the toes FK, we control the rotation of the toes as a direct rotation. Alright, so let's go back to our Espresso and this will be the final thing we want to control. So we have these 4 null objects that we want to control with these 2 user datas. First of all, and these guys should have 0 rotations because they're all aligned with the controller here. So first of all, the toes, it can go directly to the toes of k. It's set to degrees. So now by moving this, we control the pitch of the toes, which is good. Alright, so this is all set up. That was easy to do. Let's do the other guys. So again, when I move this backwards, when I move this on the negative, I want the heel to lift the leg. So it's going to control the heel rotation. Let's take the heel and let's move this upwards on the positive. So it's not the positive we want, it's the negative. We want it to rotate on the negative pitch. So let's make a range mapper. And the reason I'm making a range mapper is to limit rather than map the range. We're going to input the foot roll. We're going to use degrees, and we want to go from minus 70 degrees on the input until 0. Right? And we're going to clamp the, actually we don't want to clamp the lower, we want to clamp the upper value here. So let's connect this to our heel roll. Actually, let's put the same values on the output because we don't want to map it. So minus 70 until 0. The only thing we did is to clamp the top. So it's not going to add more value after 0. Now by adjusting the slider, we can see it's going backwards with the heel, but after 0 it's not doing anything because the range mapper is stopping it. Alright, so this is set up, this is getting out of the way. Let's move on. Let's make a new range mapper, and this time we want it from 0. And how many degrees? Let's say until 70. Let's try this. So from 0 to 70. And bring it on the toes roll. So on the toes roll, not on the toes roll, on the ball roll. So when we move the slider on the positive side, it's going to start bending the leg until 70 degrees, and then it's going to stop. Alright, and then let's make another range mapper. I'm just control and dragging this and connect it, and we want this. So from 70 to 120, and this time we do want to map the range. We want to set it, so this is 50 degrees, right? From 0 to 50 on the toes roll. And now something we didn't do is we didn't clamp the lower rotation, and this time we do want to clamp the lower rotation. So it's going to ignore all the values before 70, and here we want to do the same, because right now if I move negatively, yes, the heel will go up, but the ball roll is also going to rotate negatively, so we also want to limit this. We want to clamp the lower. So here we want to clamp both the lower and the upper in this ball roll and toes roll, but on the heel roll we just want to clamp the upper because the lower is free if we want to overshoot it. And speaking of which, on the toes we don't want to clamp the upper, we still want to be able to overshoot it. So now it's using the toes roll more than 70 degrees, and actually I'll get back to this. The thing is that after 120 degrees I can still rotate this because I disable the clamp upper, and lower than 70 degrees I can still rotate this if I want to. If I'm here, for example, and I want to make a really extreme pose, and I'm already using the heel roll instead of my controller. Anyway, it's up to the animator to use it as he pleases. Now something I also want to do to make it further is, alright, here I'm using the ball roll, here I'm using the toes roll, but I want to make it straight again. I want to reduce the effect of the ball roll. So let's make this a tiny bit more elaborate. Let's give some space over here, fold the ball roll, and make another range mapper, right? So before, as far as the ball roll is concerned, from 0 to 70 degrees, the ball roll is rotated from 0 to 70 degrees. It's clamped before that and after that, so it doesn't care what's happening before and after. Now, we want from 70 to 120 degrees to roll this back to 0. So this is going to go from 120, it was 70, so at 70 degrees it's going to be 70. At 120 degrees it's going to go back to 0. But how are we going to connect this? This only has one port. Now the way to connect this is we need to make some logical expression. We need the espresso to be able to decide. So let's make a new node, and on the logic category, let's bring up our condition. Let's connect this to the inputs, and we have a switch here. And this switch is going to decide which of the inputs is going to come out of the output. So if it's 0, it's going to choose the first node. If it's 1, it's going to choose the second node. And by the way, we can make more inputs if we want to. So we need to compare. Let's make a new node, a compare node this time. And because Espresso is not working with degrees, but is working with radians, let's convert our value here first. So let's make a new calculate Espresso degree. So this is going to convert the radians to degrees and put it on our compare node here. And we want to compare if it's greater than 70 degrees, right? And then put it on our switch of the condition. So let's think what it's doing. Here it's giving out its radians, turning them into degrees. We can use degrees values to compare it. Now, if it's not greater than 70 degrees, it's going to give out the value of 0. So it's going to choose the first node here, which is the one that is controlling the range from 0 to 70. If it is greater than 70 degrees, it's going to give the value of 1, which means true, and it's going to select the second node here, which is the node that's controlling what will happen after 70 degrees. So now we're able to combine these two nodes into one port here, and we can see, so on the negative side is using the heel roll, from 0 to 70 is using the ball roll, and from 70 to 120 it's reducing the ball roll while using the toes roll at the same time until it's straight. So now we made two simple sliders to make some animation. Of course, we can make more sliders and control these guys individually, but for the simple eye key like this will do. Now let's organize things a little bit. Let's put all the rigging parts in a new layer. So I'm going to select these guys, and I'm going to make a new layer, and I'm going to name this rig parts. And actually it's quite common if you want to make a new layer just for the joints that are binded to your mesh, because sometimes you want to bake them, you want to export them or whatever. So let's make a new layer for them also, and it will be the binded joints, right? And the next thing I'd like to do is to just make a right leg. I don't want to make all this stuff again, right? And I'm going to use another tool from our character menu to do that. That is going to mirror everything I did. But since I already made parenting for the mesh, in this case, I want to take the mesh with me also. So I'm going to unlock the mesh. So I want to take everything that is left. First of all, I'm going to make a null here, and I'm going to name it left leg everything. All right, and let's drop our controller, our joints, and our left leg mesh here. And actually, I had a right leg mesh already, but I'm going to delete this for now. So delete this, and so we have our left leg everything. This is all the stuff that consists our left leg. And on the character menu, I'm going to bring the mirror tool. Let's go to the attributes of the mirror tool. Let's bring everything here. So first of all, the coordinates is going to choose the view. So we want to look at it on a view that we want to mirror it. Then, by default, it's going to use rotate mode to mirror the axis, and we're going to see if it does a good job or not. We can decide whether to keep it or not. Then we have the naming that we want to adjust a little bit. We want to replace the L underscore with R underscore. And yeah, let's try this. Let's hit mirror, and we see it mirrored our leg, but some things are not perfect. And most of the time you will need to make some adjustment after the mirroring. You can change, for example, the axis. You can try different combinations here. So for example, YZ, and let's try this again. That didn't work. Let's try this again, and you see this time it worked. At least it seems it worked. But maybe you will find some inconsistencies still. Let's try to move this. It's working properly. You can see our foot roll is not working because the rotation values are probably wrong. Let's choose all the nulls under the leg control, and let's unfreeze their transformation. And we can see it's still it's not working properly. So basically, as I said, we would need to make some adjustment. Let's bring our mirror tool again. And I think the rotate does a pretty good job most of the time. Let's use this. We can see, of course, in this particular case, it's not mirrored properly. This is flipped, but let's take a look inside the rig. Let's go to the toes, and on the constraint here, let's change the up vector from x minus to x plus. Let's give it the benefit of a doubt and just change this. Let's take a look at our nulls here. They seem to be okay, and we can see our user data are also working properly. So that seems good enough for me. Now we have a right leg and the left leg, and we have our layers here. We can hide our rig parts and lock them. We can hide our joints and lock them, and we can lock the mesh. So we only have our controls. Let's change the color of our right control from blue to red, and let's make a new layer just for the controls. Let's select our controls and make a new layer so we can easily select or hide our controls. I'm going to make this, yeah, never mind. Let's just keep it like that. And now that I finished mirroring, actually, let's unlock the mesh and let's drop it under the mesh null over here. And take our controls, bring them out. All right, let me unlock this and organize my hierarchies. I'm going to make a new group, which will be called controls. And I'm going to drop all the controls under the controls group and make a new group that's going to be called joints and drop my joints groups under it. And the left leg everything and right leg everything, we don't need them. Now I'm going to make the layers for these. Now for the controls layers, I just want the controls themselves to be the layer. So I'm going to leave it without layer. And again, let's log everything. And yeah, that's good enough. Now, of course, we want the body. So let's unhide this. And let's make a new control for it. Let's make a control that we can see which way it is aiming. So let's make a rectangle and bring it on the XZ plane. Let's bring it on the same height as the body. Make it smaller, make it editable. Take these 2 points and shrink them so we can kind of see which direction it's aiming. And I'm going to take these points also, condense them a little bit. Alright, so this will be the body control. Bring it to the controls, put it on a layer. Let's call it body control. And we want to constrain our body to the body control. Let's make a PSR constraint. Let's change the color, make it green. So this guy is controlling the body, but the legs are not following. So let's go back, unlock my joints, and I just want the top parent of my IK chain to be following the body control. Now what I'm gonna do is I'm going to make a couple of null objects out of these thighs. And it's a good chance to use another command actually. Let's select our thighs object here, and from the conversion menu of the character menu we have a convert to nulls. This can convert the whole joint hierarchy to nulls. So let's try to run this, convert to nulls, and you can see it created a null for our L thigh and our R thigh. So let's take these nulls, drop them under the body control, so they're children of it, and let's select our L thigh and R thigh and make a constraint tag, go to the attributes, enable the PSR. So we want the L thigh to be constrained at the L thigh null, the R thigh to be constrained at the R thigh null, and I'm going to add the prefix. I forgot the name actually. The suffix. All right, I'm going to add the suffix _t to these nulls. So I don't want objects to have the same name exactly. So maybe I will need to make a script, or I will need to filter them at some point. So I'm trying to have some naming conventions and different names for each object. All right. And finally, the last thing I want to do is to make sure that the priorities are correct. So if I move the body and I undo, I want everything to refresh properly. So everything seems to be refreshing properly. Now, what could go wrong is if these constraints were executed after the IK tag. So first, you see now there is a big problem. first the ik is executed, and then the joins, the whole chain, the whole hierarchy is being moved. So this is not good. This is not what we want. We want first the joins to be moved, the hierarchies to be moved, and then the ik to be executed and align all the joins of the hierarchy properly. So there we have it. The last thing we want actually is these two pole vectors that we cannot see anymore. First of all, let's freeze the transformations of all of our controls. So all our controls can easily be resetted to their default position. And we want our pole vectors that are hidden in here. And I think we put them on the it's not these guys, it's these guys. We put them on this layer here, but actually we want to make controls out of these pole vectors. And well, we can just use null controls. Actually, we can use them directly as controls. So let's just bring them on the controls hierarchy here, and let's make an octagon or something for them. And let's just paint them into the controls. So their rotation actually is not important, and so I'm going to leave them oriented at the camera. I'm just going to give them a different color. So usually the pole vector is purple, and yeah, why not? Purple sounds good to me. So these are the pole vectors of our joints. Great, and we want these two nulls that we made. These are part of the rig. Let's add them to the rig parts layer. All right. Now let's lock everything except our controls. Let's hide everything we don't want to see. And we build a basic rig with IK and inverse foot. So if you watched the whole tutorial until now, then I salute you. Congratulations. I know it's been lengthy, and well, I hope you find this useful, and see you next time.